2.7, use absolute value functions and transformations. So first we're going to worry about an absolute value function. So f of x equals absolute value of x would be my parent function. So that would be that base function that all the other absolute values are based on. Think about how if I'm looking at an absolute value, if I put a positive number in for x, I get a positive number out. If I put 0 in, I get 0 out. But if I put a negative number in for x, I'm going to get out a positive number. So that's at its heart what an absolute value function really does. It's going to make things positive. So because of that, I end up with this V shape. And my pattern for my graphing, because I am graphing essentially like y equals x in this direction, my pattern is up 1 over 1. And then, so my pattern's 1, 1, 1, 1. And same thing kind of for this other direction. It's like having a negative 1 slope. But if I'm starting at the vertex on both sides, I'm going up 1 and then 1 to the right. So we talk about the pattern being 1, 1, 1. Now I can look at a little more interesting absolute value. A lot of times we'll write it as absolute value of x minus h and then plus k. Notice the h is inside my absolute values with the x and my k is outside. That would have a vertex of hk. So notice that my h is opposite in sign, but my k is the same sign. That's going to be really important for some of the problems that we're doing. So a transformation, what does a transformation do? So transformation could change a graph's size, shape, position, or orientation. So changes a graph's size, shape, position, or orientation. So we could be stretching it, we could be shrinking it, we could be flipping it upside down. So we're really, for 2.7, we're taking absolute value functions. We're looking at all the different ways you can manipulate a graph. So I need to go ahead and scroll up really fast. What is a translation? A translation is just going to change position only. So changes, I have no idea why this is being a pain right now. Changes position only. So it does not change the size, shape, or the orientation, and it's going to move a graph horizontally and or vertically. All right, so I'm going to try moving again. We'll see if this can be a little bit smoother this time. So for example 1, it says we're going to graph the absolute value y equals absolute value of x minus 1 plus 3 and compare it with the graph of y equals absolute value of x. So in order to graph this, I need to figure out my new vertex. Remember I told you about how inside my absolute value, I had the opposite sign and then outside was the same sign. So my vertex here, even though it says x minus 1, will be a positive 1, comma, this says plus 3, so positive 3. And I know that my pattern is that 1, 1, 1, 1. So let's go ahead and graph this one. So first I'll make the vertex 1, 3. And then I'll go up 1 over 1 on both sides. And I'll draw my graph in. And then I want to compare that to my parent function. So my parent function would be centered at the origin, and it would be up 1 over 1. So if I had to compare this, I would say that it has been translated because I did not change the shape, size, or orientation. I only moved it, so it's going to be translated. Let's see, it went 1 unit to the right because I had an x minus 1 here. I moved my vertex from 0 to 1, and then my vertex for the y went up 3 because I moved from 0 to 3. So I translated it 1 unit right, 1 unit right, and 3 units up. So we did do a little bit with some of this language earlier, talking about how graphs are changing and moving, and we're kind of exploring that some more in this section, and we're using these absolute value graphs. So I have 2 more graphs now. Now I've got a number in front. So I have a 1/2 in front of this first absolute value graph, and the second one is being multiplied by -2. And we're going to compare to the graph of y equals absolute value of x again. So these numbers that are in front, this number, that 1/2, is going to multiply my pattern. So when I go to graph y equals 1/2 x, or 1/2 times the absolute value of x, my vertex will be 0, 0. But this time, instead of my pattern being 1, 1, 1, 1, my pattern is 1/2, 1/2, 1/2. So let's try this. I'm starting it at 0, 0 still, but I'm going up 1/2 a unit and over 1. So I'm not changing my y direction. I'm still going over 1 to the right or left. I'm not changing my x direction. What I'm changing is that vertical pattern, how much I'm going up by. I go up another 1/2 unit, and now I'm at this point here, and over 1, up 1/2, over 1. It's almost like just having a 1/2 slope. That's kind of what we notice. Same thing in the other direction. And my points are really kind of hard to read here. They're really small. It's kind of like having a 1/2 slope in both directions. I am just going to redraw this. I don't like the way it's looking. So let's see if I can get some better points. 1/2. That looks much better. And then let's see if I can do the other direction. So I'm always going up 1/2 a unit, but then instead of, when I go to the right, I'm still going right or left 1. So what I notice is that it's been vertically shrunk. Instead of going up 1 unit, I'm going up 1/2 a unit. So it's vertically shrunk or vertically compressed by a factor of 1/2. And just to see that parent function with it, I'm going to go ahead and graph up 1 over 1 so we can take a look at that also. And so you can see that the red graph versus that blue graph right below it, each of those y values is twice as big. If this y value right here is at 4, on the blue graph, it's only at 2. So it really has changed all those y values. For my second one, I am looking at y equals -2 times my absolute value of x. So now my pattern will be -2, -2, -2. And my vertex, of course, is still 0, 0. I don't have a number adding or subtracting inside or outside, so it starts at 0, 0. So now when I go to graph, I'm going to go down 2, 1 to the right, down 2, 1 to the right, and then down 2 and 1 to the left. So again, I am multiplying in my y direction only. I am not changing anything in my x direction right now. And we'll go ahead and graph that parent function again, just so we can really compare. So we can see now that our graph was, let's see, our graph was flipped upside down. So we're going to call that reflected in the x-axis. So really it's over the x-axis, right? But we call that in the x-axis in math. Let's see, we also stretched it vertically. So each of my y values was twice as big. I didn't change anything in the x direction at all. Remember, I was still going one to the right, one to the right, one to the right, but I went down 2 instead of just 1 unit. So we also had, come on, back up here. We also had a vertical stretch by a factor of 2. All right, so let's go ahead and move on to our next pattern. Oh, I guess now we're filling out a table. So we looked at examples of this, but now we're going to kind of go through and put some words and give some values to this. But I do want to first mention that when we're affecting graphs, the order that we do things in really matters. So first, we stretch or shrink. The second step is reflect, and translate would be my third step. So sometimes with a graph, and it's really easy with a parabola or with an absolute value, but when we get into weird shaped graphs, like we'll do for our last example, I need you to know that first we worry about stretching or shrink. We have like an order of operations to this. Then we worry about reflections, and then third is translating. So when I talk about A, I am talking about if I have a number in front of my absolute value. So if I look at this absolute value of x minus h plus k, but now I put this a out in front, that's what I'm talking about. So here I'm talking about a number, an absolute value of a that's greater than 1. So that means if I'm multiplying, if this number I'm multiplying by is like 1.5 or 5 or 7, I don't care if it's negative or not, the negative is going to flip it upside down. But what I am looking at here is something that's bigger than 1. So examples of this, like I said, could be 2 or 5/4, or it could even be a negative number, like -3, because when I take the absolute value of that, it's +3. I'm still stretching it. So this is going to be vertically stretched. Or elongated is another word for it. And the graph will be narrower than if I was just looking at the parent function. In this case, f of x equals absolute value of just x. So when we vertically stretch it, it becomes narrower. So now over here, if we're looking at the absolute value of a is less than 1, so that could be like a 1/2, or it could be a -3/4, right? Absolute value of that is still 3/4. It could be 2/3. So this is going to vertically shrink or compress. Vertically compress. And the graph is going to be wider than the parent function. So in this case, our parent function, of course, is just f of x equals absolute value x. So I kind of like that I put some examples of a values out here on the right. For a absolute value of a less than 1, I want to put some over here also. So this would be like 2, 3, -5, 7/2. So like these numbers. So I'm either stretching or I'm compressing. Reflection, when a is negative, the graph is reflected in the x-axis. So scrolling on here, I'm getting way better at the scrolling and writing. I just want to point that out. So for example 3 now, I have a number in front of my absolute values. I've got a number inside, I've got a number over here. So I know that the 3 and the 2, those are going to be the ones that do the shifting part. I knew the 1/4 part, that 1/4 is going to be multiplying my pattern. So the 1/4, I always have to do the multiplying part first. So the 1/4 is going to vertically shrink. So I'm going to vertically shrink or compress. I like compress because that's really what I'm thinking about seeing. It looks like something just smashed that graph down vertically. So it's going to be vertically compressed by 1/4. And my graph is going to be shifting because of the translation. So it's going to translate. And again, the number inside my absolute value is always opposite. So if it says x plus 3, I'm going to move it in the x direction, but not a positive 3. It's going to move negative 3. So I'm going to translate this one 3 units left. And outside, I have a minus 2. That's always my same sign. So 2 units down. So remember, the one inside is always opposite. It affects the x direction. The number outside affects the y direction, and it's just the same sign. So in order to graph this, I would need to remember that my pattern is now 1/4, 1/4, 1/4, which will be a little bit tricky to do, only moving up 1/4 of a unit. I had a hard time with half a unit, so 1/4 will be challenging. And my vertex, opposite sign, same sign, will be -3, -2. So I'm going to start my graph at -3x, down 2 for y. And I'm going to do my best to move up 1/4 of a unit and then over 1. And then 1/4 and over 1. And then 1/4 and over 1. And then I'll be at a corner point again. So let's do one more of those, up 1/4 and over 1. And now I'm at the half. And now I'm at 3/4. And now I'm at that corner point again. And then when I copy onto the other side, I'm not going to make all those points. I'm just going to make those kind of easily graphable ones. There, that looks better. So you can see how the graph does get a lot wider as I am vertically compressing it. So for our last example, we're going to show that we can extend these ideas of manipulating graphs, and we can use them for some kind of random graph. And this isn't any kind of absolute value or anything. Don't try to write an equation for it. We can just come up with these random graphs in math and manipulate them. That's really what we're doing here. So what I do want to remember, though, sorry, I'm not trying to make you guys dizzy, is that when I do my transformations, that first, remember I told you our first step is always stretch or shrink. Step 2 would be the reflect step, if it's reflecting. And then step 3 would be translating. So that means moving up, left, right, or down. So let's go ahead and take a look at A. A says -1/3 times f of x. So this means what I'm really doing is I'm multiplying my y values by 1/3. So that's really vertically shrinking by 1/3, or vertically compressing. So vertically compressed by 1/3. So that's what I'm really doing there. And that's my first step, my stretch or shrink step. The second step is really reflecting. And because I have a negative, I am reflecting on this one. So my second step, I think I want these numbered instead of what I had here. Let's go ahead and erase that star and put a number 1 here. My second step is going to be to reflect in the x-axis. I know some of you are wondering, why are we always reflecting over X? Well, we can reflect over Y also, but it is just too much this year. So we're not going to be doing it this year at all. So I want to think about where my original points were. So if I have a point at 0, 0, my Y value is 0. When I divide that by 3, it's still 0. If I reflect it, it's still 0. I can't take 0 and make the negative 0. So I know that this point here is still going to be the same. Now I want to think about this next ordered pair. So I'm really taking this Y value and I'm dividing it by 3, and I'm flipping it. So I'm really dividing it by a negative 3, aren't I? So my new ordered pair would be negative 3, comma, negative 3 divided by negative 3 would just be a 1. So I've taken that Y value and I'm compressing it by a third. And so if I look at it on this graph, I could even think about it in terms of squares. Like this is 3 squares away. If I'm compressing it by a third, now it's only going to be a third of as far away from that axis. But then because I'm also reflecting it, instead of being on this side of my x-axis, it would be up here instead. And that's where I get that negative 3, 1 from. So one is kind of more of a picture explanation, and the other one is more of a mathematical explanation. So negative 3, 1 will now be here. So again, I've taken this Y value and it said take your Y's, multiply by negative 1/3, which is the same thing as dividing by negative 3. So that's what I've done. Negative 3 divided by negative 3 is a positive 1. Now I have one more Y value to move. I have to take this point over here and I need to move it. So if I look at doing the same thing, and on this one, instead of dividing by negative 3, I'm going to take that negative 6 and I'm going to multiply by negative 1/3. That's what it's telling me to do. I just want you to see that dividing by 3, sorry, here I go moving this thing around again. I'll get better at it. So my X value will still be 3, but negative 6 times negative 1/3 would be a positive 2. So my whole graph has radically changed. I have this tiny little graph now. So I have taken my Y values and they're now a negative 1/3 of what they are. But I have not changed X. I did not change X at all. There was nothing inside my parentheses with X. So I only had negative 1/3 times my f of X. F of X we know is Y. So we only changed Y's. We did not change X on this graph. Sometimes it helps to see with that original parent function in there. So here's my original parent function. And again, we took each of our Y values, we divided them by negative 3, and then we just plotted it. That's all we had to do. So for B, it says f of the quantity x minus 1 and then plus 3. So it's always opposite sign, same sign. So I am going to move this so that my new vertex, instead of being 0, 0, is going to be like 1, 3. So I am really translating. So I don't have any multiplying on this, but I don't have any negatives outside of that f of x. So I'm not doing stretching or shrinking. I'm not doing reflecting. I'm only translating. So I'm going to translate opposite sign here. So in the x direction, instead of minus 1, it'll be 1 unit, 1 positive unit. So we'll go to the right. And then this one's always the same sign. It affects my Y. So Y direction would be up or down. It says plus 3. So we'll move 3 units up. And like I told you, I could think about this original graph kind of having a vertex. And I don't want to think it's a parabola. It's not a parabola. It's not an absolute value. This is just some random f of x graph that we've given to you. So here I'm at 0, 0. When I move that to 1, 3, it will now be here. 1, 3. And then all my other points are going to get moved 1 unit right and 3 units up as well. So maybe the thing to do again is to graph my original function. Okay, that point just moved on me, and I have no idea why. So let's erase him. So I'm going to graph at 0, 0, negative 3, negative 3. This one's 3, negative 6. And in order to graph my new function, All I have to do is take each of these points. So this point here, 3, negative, negative 3, negative 3. Now I'm moving it 1 unit right and 3 units up. So all I did was move it 1 unit to the right, 3 units up. Same thing over here. For my third point, I'll move it 1 unit right and then 3 up. So for this one, my graph should look the same. All I did was translate it. I didn't multiply by anything. I didn't reflect it. All I did was just move the position. So I did not change when I'm translating. Remember, we don't change the size, the shape, or the orientation. So now, sorry about that. Still learning this, I'm telling you. So now I'm going to try part C where I do a little bit of everything. So for this one, I'm definitely going to want my parent function written out. And I'm going to do it in red again because I like color coding stuff. And I'm getting really good at drawing this parent function now. Hopefully you are realizing that if you're confused or if this is going too fast, that you can just pause at any moment and then go slower through the math. I want a really pretty looking parent function, and I'm apparently just not going to connect this line well today. That is the best I can do. So on this one, I know I'm going to be stretching vertically by 2. I am going to be reflecting in the x-axis. And then I'm going to be translating. So I have 3 steps. Remember, I told you we had to do the stretching or shrinking first, and then the reflecting, and then the translating. And I'm back to numbering my steps again because there are so many. The last one, I didn't even really worry about it because we just had to do one thing. This one, we have 3 different parts. So we're going to translate it. If it says x plus 1, we are really moving negative 1 in the x direction. So we're going to move 1 unit, and the negative x direction would be left. Think about how on a number line, as you go to right positive, and then the left is negative. There is a plus 4 outside the parentheses. So that means that one's the same sign. So we're going to move 4 units up. Inside is always affecting x. Outside is always affecting y. And it's always opposite sign, same sign, every single time. So 4 units up. So this would be a lot to do this graph in one stage. So I'm going to do 1 and 2 for now. And then I'm going to do 3 because it's just a lot to do. So if I am going to stretch vertically by 2 and reflect in the x-axis, I've got to remember I'm not changing my x's. So this point over here that's negative 3 to the left, it's still going to be negative 3 to the left. But now, instead of having a y value that's negative 3, I'm going to be taking that y value, and really I'm multiplying it by a negative 2. So I'm still going to have an x of negative 3, but now my y is going to be a positive 6 because I am reflecting it over my axis, x-axis, or in the x-axis, as we like to say in math. And I'm also stretching it, and I'm also multiplying it by 2. So negative 3 and then positive 6. So this isn't going to be my final answer, but it is going to help me get the final answer. For 0, 0, I know I'm taking my y value, and again, I'm just going to be multiplying my y value by negative 2. So that doesn't do anything. 0 times anything is still 0. This point's in the same spot. On my last one, negative 3, negative 6, and I need to multiply that one by a negative 2 as well. So now we'll have 3 and then positive 12. So positive 12 is going to be right here. So this is not my final answer. I have one more step to do. I still need to translate this. 1 unit left and 4 units up. So I think I need to grab a new color for this. We'll make it green. So it's going to be bright. This is going to be on my final graph. And you can tell I am going to run out of space because I've got to move this 4 units up, and I was already off my graph. So each point is going to move 1 unit left and then up 1, 2, 3, 4. So we've already done the stretching and the reflecting, and now I'm just translating. So this middle point here, the one that's kind of like a vertex, except I don't want to think about vertex in terms of a parabola or an absolute value because this isn't really an equation. It's just a random graph. So this point's going to go one left and then up 1, 2, 3, 4. And then this last tricky point that's going to be off into space, it's going to go 1 unit left and then 1, 2, 3, 4. There we go. So this is going to be my final answer. I'm all set on that graph. If you have questions, as always, please contact your teacher. Have a great day.